In this video, we will be learning about arithmetic sequences, and our lesson will be based on the worksheet which is provided by Kuta software Infinite Algebra 2. I do not own this worksheet, but in order to teach, I will use this material so that the student who is watching this, the audience, would be able to understand further with the array of solutions that will be based according to the corresponding problems. Now, let's proceed without further ado. Um, for test 1, determine if the sequence is arithmetic. If it is, find the common difference. So, for number 1, we can see that the common difference, which is the interval in between numbers, we can see that 35 to 32, the difference is positive 3. 32 to 29, it's also positive 3. For 29 to 26, it's also positive 3. We can see that there is a pattern. The common difference value is uniform. So we can say that this sequence is arithmetic. So our common difference actually is abbreviated by the small letter d. Probably in the computer it would be italicized, but it's already quite obvious. If we see a d, maybe it connotates with the common difference. Now, for number 2, negative 3 to negative 23, the interval or the distance in between the two values is negative 20. How did I say that? Negative 3 plus negative 23 is the value that we get for the next term. So negative 23, negative 43, we get negative 20 difference. Negative 63 and negative 43, it's also negative 20. So our common difference will be negative 20. For number 3, negative 64 and negative 34, the difference is 30. 6 minus 3 is 3, and 4 minus 4 is 0. So negative 30. We have the negative sign because the two values are negative. So the rest of the values follow suit. Our common difference for number 3 is negative 30. So far, it could be concluded that the formula to find the common difference is a sub 2, a sub 2 minus a sub 1. Now, for number 4, let's base our finding the common difference with the formula. We have negative 40, this is our a sub 2, and a sub 1 is negative 30. So d is equal to negative 40 minus negative 30. So this will be plus law of integers. So we get d is equal to negative 10. How do we know if this is correct? Let's see. This is negative 10, negative 10, negative 10. So negative 30 plus negative 10 is negative 40. Negative 40 plus negative 10 is negative 50. And negative 50 plus negative 10 again, we'll get negative 60. That's how mathematics works in terms of arithmetic sequence. So yes, indeed, this is the right answer. For number 5, negative 7, negative 9, negative 9 minus negative 7, our answer for D is negative 2. Let's just place it there. Okay, number 6, D is equal to a sub 2, which is 14. A sub 1 is 9. 14 minus 9, D is equal to 5. That's how we find the common difference. Basically, everything in this, numbers 1 to 6, is all arithmetic. The sequences are arithmetic. So let's move on. Given the explicit formula for an arithmetic sequence, we know the explicit formula, which is this. These we're called to find the first 5 terms and the term named in the problem, which is these terms. So I prefer, depending on your like, I'll just show you how I solve these problems. So to find a sub 34, a sub 34, we know that we have the explicit formula. We could make good use of it this way. So we know that n is 34 because a sub n, a sub 34, we know what it is. So a sub 34 is equal to negative 11. We're just basing our own equation according to the general explicit formula, plus 7 times our n is 34 again. So let's proceed. We'll just simplify the right part of the equation. So negative 11 plus 7 times 34. By the way, I think it is vital to use the calculator in order to solve these problems. And I hope you have your calculator with you as we go along solving this worksheet, because solving it manually will only cause a big burden. So a sub 34 is equal to 227. Now, in moving on, we'll find the first 5 terms, which is basically a sub 1 to a sub 5. So for a sub 1, we'll still make use of the explicit formula that is given. So a sub 1 is equal to 11 plus 7 times 1. We'll just place the expression again in the calculator, and we get negative 4. A sub 1 is negative 4. For a sub 2, a sub 2 is equal to negative 11 plus 7 times 2. Our answer in the calculator, it says a sub 2 is positive 3. So for a sub 3 of number 7, a sub 3 is equal to negative 11 plus 7 times 3. We put it again in the calculator. Our answer would be positive 10. For a sub 4, the same equation follows suit. A sub 4 is equal to negative 11 plus 7 times 4. A sub 4 would be equal to 17. And to find a sub 5, a sub 5 is equal to negative 11 plus 7 times 5. Our answer would be 24. So we're finished with number 7. Just to give you a brief understanding of what's been learned, we can derive from here that the common difference is 7. D is equal to 7. You can see that the interval in between, like 3 minus negative 4, we get 7. So in order to get a sub 2, if we add negative 4 and positive 7, our answer would be positive 3, which is a sub 2. And to find a sub 3, we use a sub 2, which is 3, plus the common difference, and our answer would be negative 10. 7 plus 3 is equal to 10. And further on, to find a sub 4, we just add 7, we get 17, and we add another 7, we'll get a sub 5. So that's how arithmetic sequence, the concept of arithmetic sequence works. Number 8. To find a sub 39, again, substitute. I won't be speaking much words on the following problems anymore. The concept is already well explained, and we'll just solve faster. We don't want to make this video super long to the point that it gets really boring. So yes, negative 100 times 39. A sub 39 is equal to 65 minus 100 times 39. Our answer is negative 3,835. So, let's find a sub 1, the first term that's being called to solve. A sub 1 is equal to 65 minus 100 times 1. 1 is our n in this scenario. 65 minus 100 times 1, we get negative 35. For a sub 2 is equal to 65 minus 100 times 2. We'll just copy paste the entire formula and just replace what n is, or the value of n. A sub 2 is equal to 100 times 2. It is negative 135. For a sub 3, we just replace the entire solution, duplicate. Literally, it's easy if you know, if you understand the pattern. So, given that, our a sub 3 is equal to negative 235. There you go. And for a sub 4, a sub 4 is equal to 65 minus 100 times 4. Nothing new with the solution. We just add another negative 100. We get negative 335. By the way, why did I say negative 100? That is our common difference. D is equal to negative 100. Proof, to get a sub 2, negative 35 plus negative 100, we get a sub 2. Negative 135 plus negative 100, we get a sub 3. I hope you understand. The person who's watching this, I hope you understand what's being conceptualized here. So a sub 5 is equal to 65 minus 100 times 5. A sub 5 is equal to negative 435. Alright, let's move to number 9. Less talk, more to solution. Let's go. To find a sub 27, negative 7.1 minus 2.1 times 27. Place it all in the calculator. By the way, I prefer that you use scientific calculator. I think it's only according to my opinion. It's way easier to solve using the scientific calculator, but it still depends on you. You as the student, decide on or pursue what kind of calculator you prefer using, you find easier using. But as for me, I use my scientific calculator. Now, in this case, we know what a sub 27 is now. We have two answers actually, both of which are equal to one another. Negative 319 over 5, which is a fraction, or negative 63.8, which is the decimal form of the said fraction. So whatever your math teacher prefers, do follow. But as for my teacher, she prefers to have our answers in fractions. So yes, and any of these answers are correct. But for expect in the following minutes that I'll be solving for fractions. The final answers will be in fractions. But for decimals, you can just translate them in the scientific calculator, the specific button that translates decimal to fraction and vice versa. So for a sub 1 is equal to negative 7.1 minus 2.1 times 1. Our answer for a sub 1 is negative 46 over 5. For a sub 2 is equal to negative 7.1 minus 2.1 times 2. Our answer is negative 113 over 10. Let's speed up. A sub 3 is equal to negative 7.1 minus 2.1 times 3. Our answer is negative 67 over 5. A sub 4. A sub 4 is equal to negative 7.1 minus 2.1 times 4. Our answer is negative 31 over 2. Okay, we lack space for the following numbers, so we'll have to zoom these in, make these annotations a little smaller. Not to the point that it's unreadable. We'll just maximize the space to have all of our solutions tolerable. So for a sub 5, it's equal to negative 7.1 minus 2.1 times 5. Our answer is negative 88 over 5. Okay, for number 10, our a sub 23 is equal to 11 over 8. Oops, sorry. 11 over 8 plus 1 over 2 times 23. A sub 23, we'll place them all in the calculator. 11 over 8 plus 1 over 2 times 23. Our answer is 103 over 8. A sub 1, to find a sub 1, is equal to 11 over 8 plus 1 over 2 times 1. Our answer for a sub 1 is 15 over 8. For a sub 2, it's equal to 11 over 8 plus 1 over 2, the same formula, times 2 this time. A sub 2 is equal to 19 over 8. For a sub 3 is equal to 11 over 8 plus 1 over 2 times 3. Our answer for a sub 3 is 23 over 8. For a sub 4, the same formula. Maybe I won't be writing it anymore, but we'll just replace the entire formula with 4 as n. There you go. Oops, sorry. There you go. Our answer is 27 over 8. For a sub 5, the same formula, but this time we have 5 as our n value. A sub 5 is equal to 31 over 8. Alright, let's move on to numbers 11 to 14. So the instructions say, given the first term and the common difference of an arithmetic sequence, find the first 5 terms and the explicit formula. Something new is going on here. We're tasked to find the explicit formula. How? Well, basically, our explicit formula is based on this general equation. A sub n is equal to a sub 1 plus d times the quantity n minus 1. That is our general explicit formula. But given that we have our a sub 1 quantities and our common difference, we know that we can further make our explicit formula a little more specific. So for a sub n, number 11, a sub n is equal to a sub 1, which is 28, plus common difference, which is 10, times the quantity n minus 1. In this case, let us simplify. So distributive property, one of the laws of the exponents, distributive property. I hope you are the audience, you are able to Remember what you've learned in your earlier days in high school, because they will be really important. They'll be really necessary to learn in order to further study the concept of arithmetic sequences, which, according to my research, is related to pre-calculus. So this lesson is preparing our students to study what we call calculus. So a sub n, 10n is, if we multiply 10 and negative 1, we get negative 10. 28 minus 10 is 18. This is our explicit formula. Alright, so finding the first 5 terms, we already know what a sub 1 is, which is 28. So that's already a head start. For a sub 2, a sub 2 is equal to, we'll make good use of the explicit formula. It's very useful. 10 times 2 plus 18. A sub 2 is equal to 38. For a sub 3, we use the same formula again. A sub 3 is equal to 10 times 2 plus 18. A sub 3 is, oh wait, sorry. This is supposed to be 3. So 30 plus 18, 48. We could already derive from here that we know the common difference is 10. D is 10. There. So obviously we don't really have to use the formula anymore. A sub 2 is 38, then the next, which is a sub 3, is 48, then a sub 4 is 58, a sub 5 is 68. This is actually one of the easiest parts of arithmetic sequences. If we know that the common difference is a fixed number like 10 or maybe 5, it's not a number like even, it's not an even number, it's not an odd number. It's like 10 is a really common number, so it's easier to solve without a formula. I hope you get what I mean. Alright, we've solved number 11. Let's proceed to number 12. So for the explicit, we'll just abbreviate it as expli. A sub n is equal to negative 38, which is a sub 1, plus negative 100, or minus 100. In other words, we simplify this. Negative 100 n and 100, positive 100 plus negative 38 or minus 38, we get 62. So this part, our explicit formula is negative 100 n plus 62. For a sub 1, our answer is already been given. A sub 1 is equal to negative 38. For a sub 2, a sub 2 is equal to negative 100 times 2 plus 62. Negative, place it in the calculator. Negative 100 times 2 plus 62, we get negative 138. Alright, for for a sub 3, we won't be using the formula anymore. A sub 3 is equal to negative 138 plus negative 100. A sub 4 is negative 238. And furthermore, I'm so sorry, this is a sub 3, not a sub 4. For a sub 4, which is here, a sub 4 is equal to negative 138, actually negative 238 plus negative 100. A sub 4 is equal to negative 338. Alright, so for a sub 5, we'll just add another negative 100 to negative 338. Our answer would be negative 438. Okay, let's move on to number 13. Our explicit formula, a sub n is equal to negative 34 minus 10 times the quantity n minus 1. A sub n is equal to negative 10n minus 24. Why is it minus 24? Negative 34 plus 10 is negative 24. There you go. A sub 1, we know the answer already. It's negative 34. To find a sub 2, we add negative 34 plus negative 10, we get negative 44. That is our a sub 2. For a sub 3, plus negative 10, so negative 44 plus negative 10, we get negative 54. For a sub 4, negative 54 plus another negative 10, we get negative 64. And for a sub 5, you could already guess the answer. It is negative 74. Alright, for number 14, explicit formula. A sub n is equal to 35 plus 4 times the quantity n minus 1. And a sub n is equal to 4n plus 31. That is our final answer. Okay, a sub 1 is equal to 35. We know what a sub 1 is already. For a sub 2, 4 times 2 plus 31. 8 plus 31 is 39. For a sub 3, we just add 39 and the common difference, which is 4. A sub 3 is equal to 43. And a sub 4 is equal to 43 plus 4. A sub 4 is 47. And you could already guess by the looks of it, 47 plus 4, 47 plus the common difference is 51. So this is our a sub 5. Alright, we finished the first page. Okay, let's move on to page 2. Given a term in an arithmetic sequence and the common difference, find the first 5 terms and the explicit formula. It's the same instruction as the earlier one, but in this case, we have a different given. We still have the common difference, but this time, we have a sub n, not a sub 1. We cannot solve the explicit formula without a sub 1, but we can find a sub 1 with the given, with the a sub n and the common difference. So, first we have to find a sub 1. We'll base it again on the general formula. Explicit formula, a sub n is equal to a sub 1 plus d times the quantity n minus 1. So, for a sub 1, we'll assume that our a sub n is a sub 38. We'll make good use of the two given values is equal to a sub 1 plus, which is negative 1.1, so minus 1.1 times the quantity. Our n is 38, then minus 1. So we'll just remove a sub 38, we'll replace it with the real quantity already, which is negative 53.2. Alright, so we now have the negative 53.2 at the other side. Negative 1.1 times 37. The 37 is the difference between 38 and negative 1. Our answer is negative 407 over 10. We multiply both sides to eliminate the denominator of any fraction that's suspected to be present in any equation, any algebraic equation. So in the left side of the equation, 10 times negative 53.2, our answer is negative 532. Then the other side, a sub 1 minus 407. If we transpose 407 to the other side, negative 532 plus 407, our answer is negative 125. A sub 1 is equal to negative 125. We lack space for other solutions, so we'll make this smaller. Hopefully you could still see it at normal view. There. Okay, now that we have a sub 1, it's quite a long solution in order just to find one value. But I can assure you that it's going to be worth it. If your answer is correct, you could bridge yourself to find the explicit formula. So the explicit, we'll abbreviate it as XP. A sub n is equal to a sub 1, which is negative 125, and our common difference is negative 1.1 minus 1.1 times the quantity n minus 1. A sub n is equal to negative 1.1 n, negative 125 plus 1.1 is actually, what I've seen here in my calculator is quite a high value. How should I say this? Negative 123.9. I'm not sure how this is wrong, because according to the answer key, you could also find it below the Kuta worksheet, the Kuta software worksheet. That's why these worksheets are very useful for students who are trying to learn math materials that are outside what's been given within the school premises. So yes, this worksheet is really useful, but according to my answers here, it is said to be wrong. A sub 1 is not negative 125. What seems to be the matter? 38 minus 1, we get 37. Times negative 1.1, it's negative 407 over 10. Multiply both sides with 10. 53.2. Maybe let's try not multiplying both sides by 10. I think we're getting the mistake here. I apologize for the inconvenience, making this video a little more longer. But altogether, after all, we're learning. So as for me, I'm still not that experienced with the lesson, but I'm trying my best to teach what I can teach. So if we transpose the fraction to the other side, so negative 53.2 plus 407 over 10 is equal to a sub 1. We base the left expression in the calculator, negative 53.2 plus 407 over 10. Our answer is, there you go, a sub 1 is negative 12.5. That's where we get it right. We don't multiply both sides by the denominator, otherwise we get it wrong. So to find the explicit formula, let's erase this again, make a new one. A sub n is equal to negative 12.5, which is a sub 1. Our common difference is negative 1.1 times the quantity n minus 1. Negative 1.1 n plus 1.1 minus 12.5. Our answer would be negative 11.4. Let's just remove this. Let's avoid too much solutions as much as possible. Since we have the calculator, we don't really have to write that much anymore. Okay, so finding the first 5 terms. Finding the first 5 terms meant that we'll find the terms after a sub 38 because it's given. So a sub 39 will make good use of the explicit formula. I'm so sorry. Our explicit formula is incomplete. There you go. 11.4 minus 1.1n. Or we could interchange these. Negative 1.1n minus 11.4. Okay, to find a sub 39, it's equivalent to 1.1 times 39 minus 11.4. Pan the entire expression in the calculator. Then our answer would be 31.5. Now, this time I'm using our final answers. I'm basing them in decimals. A while ago, I've been basing them in fractions. Just to show you the flexibility of mathematics. Okay, so for a sub 40, we just replace our n value. A sub 39 is negative 31.5. I forgot to place the negative sign. Honestly, no. I don't think we're trying to find a sub 39. We're trying to find a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. So, for a sub 2, it's equivalent to negative 1.1 times 2 minus 11.4. Negative 1.1 times 2 minus 11.4. Our answer is negative 13.6. For a sub 3, a sub 3 is equivalent to negative 1.1 times 3 minus 11.4. Our answer is negative 14.7. For a sub 4, it's equivalent to negative 1.1 times 4 minus 11.4. Our answer is a sub 4 is equal to negative 15.8. For a sub 5, a sub 5 is equal to negative 1.1 times 5 minus 11.4. A sub 5 is equal to negative 16.9. Alright, we finished number 15. Let's move on to 16. A sub 40, find explicit. Let's find a sub 1. A sub 40, which is negative 1191, is equal to a sub 1 minus 30, which is the common difference, times the quantity 40 minus 1. So, negative 30 times 39, we get negative 1170. Transpose to the other side, 1191 plus 1170 is equal to a sub 1. A sub 1 is equal to negative 21. Alright, let's find the explicit formula first. We'll find a sub 2 later. Expli a sub n is equal to negative 21 minus 30 times the quantity n minus 1. A sub n is equal to negative 30n. Negative 30 times negative 1 is positive 30, minus negative 21, minus 21 is positive 9. That is our explicit formula. So for a sub 2 is equal to negative 30 times 2 plus 9. So negative 30 times 2 plus 9, our answer is negative 51. For a sub 3, a sub 3 is equal to negative 30 times 3 plus 9. Our answer is negative 81. For a sub 4, a sub 4 is equal to negative 111. Let's not use the formula anymore for a sub 5. This time, let's do it let's do it the fun way. Negative 11 plus negative 30. A sub 5 is equal to negative 141. Okay, for number 17, find a sub 1 again. A sub 37 is equal to a sub 1 plus 8 times the quantity 37 minus 1. A sub 37 is 249, which is equal to a sub 1. 8 times 36 is positive 288. We transpose 288 to the left side of the equation. 249 minus 288 is negative 39. A sub 1 is negative 39. So, for our explicit formula, a sub n is equal to negative 39 plus 8 times the quantity 37 minus 1. Oops, I'm sorry. N minus 1. Alright, I'm just checking if ever I got mistakes in the previous explicit formulas. So far, nothing wrong. Let's proceed. A sub n is equal to 8n. Then negative 39 plus negative 8 is negative 47. So it's basically minus 47. Okay, so let's find a sub 2. A sub 2 is equal to 8 times 2 minus 47. 16 minus 47 is negative 31. A sub 3. A sub 3 is equal to 8 times 3 minus 47. 8 times 3 is 24. A sub 3 is equal to negative 23. Let's make our solutions smaller again. Okay. For a sub 4, a sub 4 is equal to 8 times 4 minus 47. 8 times 4 is 32 minus 47. Our a sub 4 is equivalent to negative 15. For a sub 5, a sub 5 is equal to 8 times 5, which is basically 40, minus 47. A sub 5 is equal to negative 7. Alright, let's move on to number 18. A sub 1. To find a sub 1, a sub 36 is equal to a sub 1 minus 7 times the quantity 36 minus 1. So for a sub 36, we have negative 276, and at the right side of the equation, negative 7 times 35 is negative 245. Transpose to the other side, negative 226 plus 245 is equal to a sub 1. Negative 276 plus 245. A sub 1 is equivalent to negative 31. Okay, so moving on, our a sub actually no, explicit formula again. A sub n is equal to negative 31 plus d, no, minus n, minus d, negative 7, times the quantity n minus 1. A sub n is equal to negative 7n. Negative 31 plus 7 is negative 24. That is our explicit formula. A sub 2 is equal to negative 7 times 2 minus 24. A sub 2 is negative 14 minus 24, which is negative 38. A sub 3 A sub 3 is equivalent to negative 38 basically. A sub 2 plus the common difference. A sub 3 is negative 45. A sub 4 is negative 45, which is a sub 3, and plus negative 7. A sub 4 is negative 52. Alright, for a sub 5, negative 52 minus 7, our answer is negative 59. Alright, so we finished this part. Let's move on to the next. Given the first term and the common difference of an arithmetic sequence, find the recursive formula. So here, we now are required to find the recursive formula and the three terms in the sequence after the last one given. So basically, we'll find a sub 2, a sub 3, and a sub 4 for numbers 19 to 22. Alright, so let's start with finding the recursive formula. We'll abbreviate it as maybe recurse. There we go. For our recursive formula, the general standard is a sub n is equal to a sub n minus 1 plus d, such that this is different with a sub n minus a sub 1. These are different from one another. So just to avoid confusion, our minus 1 is aligned with the value of n. Okay, so for our recursive formula, a sub n is equal to a sub n minus 1, and we know that our common difference is negative 1 over 3 minus 1 over 3. Then we place such that a sub 1 is equal to 3 over 5. That's how we find the recursive formula. We basically label 75% of the entire formula, and we just replace the value of our common difference, and we place such that, and we enumerate the value of a sub 1, whatever the value is. Okay, so after that, we're called to find the three terms in the sequence after the last one given. The three terms, a sub 2. Let's find a sub 2. Though there is already the recursive formula, I still advise that we use the explicit formula. It's way easier, it's more convenient, it's widely used compared to recursive formula. Okay, so a sub 2 is equal to 3 over 5 minus 1 over 3 times the quantity 2 minus 1. Place that in the calculator. Our answer for a sub 2 is 4 over 15. Okay, so for a sub 3 is the same formula, 3 over 5 minus 1 over 3 times, this time 3 minus 1. Our answer for a sub 3 is negative 1 over 15. Alright, for a sub 4, our answer would be negative 2 over 5. I won't be writing the solutions anymore. It's gonna be really redundant, and yes. Let's do it faster as much as possible. Let's make this video as short as possible. A sub 5 is equal to negative 11 over 15. Let's move on to, oh, I'm sorry, we only have to find 3 terms. We found 4 terms. Let's disregard a sub 5. We'll only find a sub 2 to a sub 4. Okay, let's go to number 20. Recurse. Okay. A sub n is equal to a sub n minus 1 minus 5 such that a sub 1 is equal to 39. That's how we display the recursive. So for a sub 2 is equal to 39 minus 5 times the quantity 2 minus 1. A sub 2 is equal to 39 minus 5 times the quantity, times 1 basically, we get 34. A sub 2 is 34. For a sub 3 is equal to, we'll just use the same formula. 3 minus 1 is 2. So 39 minus 5 times 2 is 29. Alright, for a sub 4 is equal to 29 minus 5, which is 24. Then for a sub 5, a sub 4, which is 24. 24 minus 5 is 19. A sub 5 is 19. Really sorry. I solved the 4th term. We only need 3. Oh wow. Alright, let's go with number 21. Recursive. A sub n is equal to negative 26 plus 200. I'm so sorry. Is equal to a sub n minus 1 plus 200, such that a sub 1 is equal to negative 26. Okay. A sub 2 is equal to negative 26 plus 200 times the quantity n minus 1, which is 2 minus 1. Negative 26 plus 200 is equal to, times 1 also, is equal to 174. It's not a negative, it's a positive integer. Positive 174. Okay, for a sub 3, the same formula. 3 minus 1 is 2. A sub 3 is equal to 374. For a sub 4, the same formula. 4 minus 1 is 3, so we get 574. And for a sub 5, we'd already guess what our quantity would be with a sub 5. It's going to be 774. Dang, I found the 4th term again. Let's try not repeating the mistake with number 22. Recursive. Okay. A sub n is equal to a sub n minus 1 plus 0.9, such that a sub 1 is equal to negative 9.2. Alright. Recursive a sub 2 is equal to negative 9.2 plus 0.9 times the quantity 2 minus 1. Negative 9.2 plus 0.9 times 1. Our answer would be negative 83 over 10. Or, basically, in easier terms, we have negative 8.3. For a sub 3, the solution is still the same. 3 minus 1 is 2. So, a sub 3 is equal to negative 7.4. For a sub 4, 4 minus 1 is 3. So, our a sub 4 is equal to negative 6.5. For our a sub 5, 5 minus 1 is 4. Our answer would be negative 5.6. Never really learned my lesson. Okay, let's continue. Given a term in an arithmetic sequence and the common difference, let's find the recursive formula and the three terms in the sequence after the last one given. Okay, for our recursive, just like finding the explicit formula, we cannot solve our recursive without our a sub 1. So in order to find a sub 1, again, we're given a sub n and the common difference. So a sub 1, we'll use a sub 21, which is negative 1.4. Negative 1.4 is equal to a sub 1 plus 0.6 times the quantity 21 minus 1. So 0.6 times 20 is 12. Move to the other side, transpose negative 1.4 and negative, I'm so sorry, I got lost with the solution. We have 12, negative 12 and negative 1.4. Our answer is negative 13.4. Given that, for our recursive, a sub n is equal to a sub n minus 1 plus 0.6, such that a sub 1 is equal to negative 13.4. Oops, it's not a box. Should be a box of our answer. Okay. Finding the three terms in the sequence after the last one given, after a sub 21 is a sub 22. Find a sub 22. A sub 22 is equal to negative 1.4 plus 0.6 times the quantity 22 minus 1. A sub 22, negative 1.4 plus 0.6 times the quantity 22 minus 1, or in other words, aka 21. A sub 22 is 11.2. Our a sub 23, basically we just add 0.6 with 11.2 plus 0.6 is 11.8. And our a sub 24, 11.8 plus another 0.6, we get 12.4. Alright, we found the three terms after a sub 21. Let's go to number 24. Recursive, find a sub 1. Negative 44 is equal to a sub 1 minus 2 times 22 minus 1. Negative 2 times 21, negative 42, move to the other side, a sub 1 is equal to negative 2. Alright, so recursive, a sub n is equal to a sub n minus 1 minus 2 such that a sub 1 is equal to negative 2. Alright, now let's find a sub 23, the quantity that we're trying to find after a sub 22. A sub 23 is equal to negative 2 minus 2 times the quantity 23 minus 1. Okay, so negative 2 times 22. Our answer for a sub 23 is equal to 46. And for a sub 24, a sub 24 is equal to negative 46 plus negative 2, negative 48. Alright. After we found the two terms already, let's find the last term, the third one. A sub 25 is equal to negative 48 plus negative 2, negative 50. Okay. Let's go to number 25. Recursive a sub 1 is equal to 27.4 is equal to a sub 1 plus 1.1 times the quantity 18 minus 1. 1.1 times 17 is 18.7. Move to the other side. 27.4 minus 18.7. Our answer is 8.7. Okay, so after 25, let's find the recursive formula. A sub n is equal to a sub n minus 1 plus 1.1 such that a sub 1 is equal to 8.7. Oops. Okay, let's move on. A sub 19 after a sub 18, let's find it. A sub 19 is equal to 8.7 plus 1.1 times the quantity 19 minus 1. 8.7 plus 1.1 times 18 is equivalent to 28.5. For a sub 20, a sub 20 is equivalent to 8.7 plus 1.1 times 20 minus 1. A sub 20 is 29.6. For our last term, a sub 21, basically we just add 29.6 and the common difference 1.1. Our answer would be 30.7. Alright, let's go to for numbers 26. Find a sub 1, a sub 12, which is 28.6, is equal to a sub 1 plus 1.8 times the quantity 12 minus 1. So 1.8 times 11 is 19.8. Transpose to the other side. We get 8.8. Alright, so for the recursive, a sub n is equal to a sub n minus 1 plus 1.8 such that a sub 1 is equal to 8.8. Let's move this here. Okay, there you go. A sub n, no, a sub 13 is equal to 8.8 plus 1.8 times the quantity 13 minus 1. Place them in the calculator. Our answer would be 30.4. A sub 14. A sub 14 is equal to basically 30.4 plus 1.8, which is 32.2. Now, for a sub 15 is equal to 32.2 plus another 1.8, which is 34. Alright, we finished that part. We have the last. Given two terms in an arithmetic sequence, find the recursive formula. This would be one of the most challenging parts of the entire worksheet, because we don't know what our common difference is. What we're given two terms that correspond to the general personality or the general expression of a sub n. So as for my solution, in this case, how I would solve, with what I would think of in order to solve this, I'll assume that the higher quantity, the higher a sub n, will be the a sub n, and the a sub 18, which is the lower a sub n, will be our a sub 1. I know it's confusing, but basically a sub 1 will be assumed as the lower term, which is this one. We know that 3,362 is less than 7,362, and the higher number will be our a sub n. So first, we'll be deriving our common difference from these two terms. So we'll still use the arithmetic sequence formula. So a sub 38, a sub n is equal to a sub 1, which is a sub 18, plus d times 38 minus 18, assuming that these two correspond to the general formula n minus 1. So a sub 38 is 7,362, which is equal to 3,362 plus our d. We don't know what it is, but we can say that 38 minus 18 is 20, so 20d. If we transpose 3,362 to the other side, we get 4,000. 4,000 divided by 20 is 200. D is equal to 200. Now, we know what our common difference is, but we don't know what our a sub 1 is. We can't find the recursive formula without a sub 1. So again, let's now use, actually, we'll assume that a sub n is equal to 18. I mean a sub 18. Okay, so a sub 18 is equal to a sub 1. We don't know what it is, but we know what the common difference is. So plus 200 times the quantity 18 minus 1. Whereas a sub 18, let's replace it already with 3,362. Okay, so 200 times 17, our answer is 3,400. 3,400, move to the other side. 3,362 minus 3,400 is equal to a sub 1. Our answer will be 38, negative 38. A sub 1 is equal to negative 38. Now, let's place them in the recursive formula, a sub n is equal to a sub n minus 1 plus 200, such that a sub 1 is equal to negative 38. There you go. That is our answer for number 27. Now, for number 28, let's assume again that a sub 33, the bigger one, is a sub n. The smaller will be our a sub 1. Now, let's find common difference. A sub 33 is equal to a sub 18 plus d times the quantity 33 minus 18. A sub 33, which is 84.8, is equal to a sub 18, which is 44.3, plus our common difference, and 33 minus 18 is equivalent to 15d. I mean 15 only. We just place it with d because it's multiplication. Now, transpose 44.3 to the left side of the equation. 84.8 minus 44.3 is equivalent to 40.5. So 15d is equal to 40.5. Divide both sides by 15. D is equal to 2.7. No, this is not the final answer. We'll just box it, as well as these two. We'll just encircle them as a supporting answer that will be used to find the final answer, which is in a box. Okay, so now that we know the common difference, let's find a sub 1. Assuming that a sub n is equal to a sub 18. Again, a sub n is equal to a sub 1. Our a sub n is a sub 18 plus 2.7 times the quantity 18 minus 1, whereas our a sub 18 is 44.3. So 2.7 times 17, what we will get is 45.9. Move to the other side. A sub 1 is equal to negative 1.6. There you go. Now let's assemble the recursive formula. Let's finish this once and for all. Recursive. Oh yeah, I almost forgot to place a label for the other side. There you go. Recursive a sub n is equal to a sub n minus 1 plus 2.7, such that a sub 1 is equal to negative 1.6. Okay, so this is the entire worksheet for arithmetic sequence. Thank you to Kuta software for allowing us to have to borrow this material, so that I would be able to teach the watchers of this video how to solve arithmetic sequences based on the questions posted in this worksheet. And just in case that you're not comfortable with the solutions I've made here, as well as the answers, you could always check on the answer key, which is below. So there. I'll send the link of the PDF of this worksheet. Again, I do not own the worksheet. It is only used so that I could teach better with the lesson of arithmetic sequences. And yes, without further ado, let's end the video. Goodbye and thank you.